Thank you all for coming. My name is Jamie Williamson. I am the Executive Vice President here at Scripps. Pleased to welcome you here to the front row. I see lots of familiar faces that are my colleagues and people I've met before, but I'd like to maybe have a show of hands. Who's new? First time at front row. Look at that. Okay, terrific. Well, welcome to Scripps. Maybe I could just say a few things about Scripps. We are one of the largest not-for-profit biomedical research institutes in the country. We have two campuses. We have this beautiful campus in La Jolla. We have a sister campus in Jupiter, Florida. Here we have about 150 faculty members that span all kinds of disciplines through chemistry and biology, neuroscience, immunology, structural biology, and molecular medicine. And we have about 50 faculty members on the Florida campus. One of the crown jewels of Scripps, of course, is our graduate program. We have a really fantastic set of 200 graduate students here and about 50 graduate students in Florida. Our program has been ranked in the top 10 in the country for about 20 years now by U.S. News and World Report. So we compete very effectively for top students all the way around the world. We have, in addition to basic research, we have a few institutes within Scripps. One of them is the Caliber Institute. So Pete Schultz, our president, founded Caliber about 5 or 6 years ago with a substantial gift from Merck. And when he became the president 3 years ago, he subsequently merged Caliber right into Scripps. So we now have the ability to do basic research and then translate that directly into medicines. And the licensing revenues from that will come back and fund some more research. So the other institute that we have is the Scripps Research Translational Institute. And our featured speaker today, Dr. Eric Topol, founded that institute and has been running it. And it's another crown jewel at Scripps. Eric is the master of genomics and high tech and artificial intelligence as it is applied to medicine. He was awarded the largest NIH grant that was ever awarded in the history of the NIH, which is the All of Us project that is enrolling 1 million patients in trying to collect their data and trying to improve the way that healthcare is done. And I'm sure he's going to say much more about that, so I won't say anything more. But I will say that Eric is clearly a thought leader in the field. He just has this way of distilling down information and then projecting it into the future. What are we going to do with all this genomic information? How are we going to use it? And framing the discussion and the dialogue about how we need to change healthcare in the United States. At this time, I'd like to welcome Eric to the stage, and please join me in welcoming him.
All right. Well, thanks so much, Jamie, and thanks for coming this evening. For the front row, especially the people in the front row here. Yeah, we're going to have fun. We're going to get into a new form of medicine. It's a little bit of Back to the Future. Some of you will remember 30, 40 years ago when medicine was very different, when there was a precious relationship between doctors and their patients. And perhaps there's now a new mechanism we can get there, and wouldn't that be exciting? So that's deep medicine in a nutshell, but we're going to talk about how we're going to get there, this high performance, which is a takeoff from high performance computing, of a new way to take care of all the data that's flowing now in every which way to help patients. So this is a cover of a couple of recent magazines, journals. One is about being human, the amount of data that we can see, we can work with in any person now, which is extraordinary. And then the whole idea of a data-driven medicine, which hasn't been the case really in just starting now in many respects. So it turns out that we have exceeded the number of bytes, yottabytes, and now there's a contest who should be the next unit, the next one beyond yottabytes. Some have recommended hell of a bytes. But This is just to give you a sense of how much data is being accumulated. And by the way, out of these a remarkable number of exabytes in healthcare. A lot of that is from images and also from sequencing. So the first thing is to fess up about how medicine is really very shaky today. In the US, we have 12 million minimum serious diagnostic errors a year. Now, that's a very big number. And the reason for that is because there's not enough time to review data. There's not enough cognitive aspects because things are so rushed. And there's a book that many of you have read. Danny Kahneman's really now a classic book, Thinking Fast and Slow. But we have a different form in medicine today, medicine fast and shallow. And it's very shallow, not just about time, but we just can't, as doctors and nurses, clinicians, can't get our arms around all the data about any given person. And so that has to change. This is a word cloud of, at a prestigious academic center in the country, in the South, but it's representative of anywhere else in this country. They asked, give us 2 words that describe your encounter with your doctor. And it isn't very pretty, as you can see. And this is a recent, a couple weeks ago, really great editorial by Danielle Alfrey, who's an author from New York City, a physician author. And she says, if it requires thinking, I'm sunk, because there's no time. And talks about all the tests that are ordered unnecessarily and added referrals because there's not enough time. And finally, she concludes, beyond the financial waste, modern medical practice is a petri dish for medical error, patient harm, and physical burnout. You may know this, but physician burnout, is now an epidemic. More than half of physicians suffer from burnout and 20% from clinical depression, the record number of suicides in the history of the medical profession. And not just in this country, but in most developed countries. This is a recent magazine cover, which is Death by 10,000 Clicks, because as it turns out, doctors now have become data clerks. And so they not only are trying to deal with all this in a very compressed period of time, but they don't even see the patient, literally, because there's no eye contact because they're typing on a keyboard. And this is the different specialties of medicine. They kind of all look the same, don't they? Because that's what's happened now, and it's a fiasco. So I actually have a clinic every week, and my main goal in my clinic, I thought I should change it after Michael Lewis's book, From the Undoing Project to the Undoing Clinic, because I mainly spend time getting people to get off the prescriptions or to not have the tests that they otherwise were ordered, because so much waste that's happening today because of this problem. And just to give you a little bit more grounding on that, the United States is a very negative outlier. We are the only country in the history of the world, since it's been recorded, that's had decreasing life expectancy for 3 years in a row. We also have the highest per person expenditures for healthcare, $11,000 plus. And we also have the worst infant, child, and maternal mortality of any OECD country. So this is really pretty darn shameful. And in addition to that, we just keep hiring more people in healthcare. So these are the data that show that as of late December 17, just a year and a half ago, for the first time in American history, there are more healthcare jobs than even retail. So you just keep hiring more people to have this model that doesn't work. So what we're going to talk about now is a whole new model, which is understanding each individual, the essence of the medical side of each person. And that was the subject of a wonderful National Geographic January issue, if you hadn't seen it. Everybody is unique. And we have the ways to understand each person now. And it's many layers, just like a Google map of a satellite view, a traffic view, street view. Now we have all these different layers of a person that, as far as their, not just their anatomy through scans or their physiology through sensors, all the different biologic layers, DNA, proteins, metabolites, the microbiome, and even the quantification of our environment, our exposome via sensors that can be done now. And beyond all that, there's the immunome, which this group in Israel published a recent remarkable paper about how that status of our immune system is so predictive of what's going to happen throughout our life. So just last week, the Kelly twins, Scott Kelly up in space for over a year as compared to Mark, the most detailed assessment of two human beings ever, virtually every layer that I just mentioned for these two. And it didn't bode well for anybody who's interested in going to Mars. There was a very serious cognitive hit to Scott, and also lots of things happening in his DNA and chromosomes suggesting he'd have just a year's worth of flight would be a real risk for cancer. Now, it isn't enough to assess this once. It turns out beyond the DNA sequence, which is fine to do one time, a lot of the other omic assessments need to be done on a longitudinal basis, like the immunome, as an example. So when I did this review article a few years back, I called it From Pre-Womb to Tomb. And one of my former mentors told me, Eric, you really had the wrong name for that article. It should have been From Lust to Dust. I said, you're right, Bill. It would have had a much bigger uptake. But as it turns out right now, we are seeing finally medical sequencing, not in the research silo, but it's actually happening in the clinic. It's happening here in San Diego at Rady Children's Hospital, one of our partners in our efforts, where they are sequencing sick newborns and doing that very quickly, in fact, within 24 hours. And now in children with various conditions, in the young adults and even older adults who have unknown serious medical conditions that can be diagnosed, at least a fourth or a half, just by sequencing, to be able to determine the cause of sepsis, infections that are serious, but not waiting for days for a culture to come back, cancer, genomic disease. And we have a big program here in San Diego for molecular autopsy for sudden death in people, unanticipated, where the autopsy is negative. And we work with the medical examiner to try to find for the family, so they don't have to live the rest of their lives worrying about if they have a mutation that could put them at risk. So that's a big program here at Scripps as well. So how many of you have had a polygenic risk score? Anybody had that? 2 people, 3. Okay, good. Well, that's a good reason you're here this evening. So this is MIT Tech Review, which is one of the better sources of information in this area that we're talking about tonight. And they had their breakthrough technologies last year. The number 1 was the polygenic risk score. And about forecasting your fate, not really fate, probability of getting a condition by hundreds of differences in letters in your genome, which you can get through a chip, a 1 million chip, which is run by places like 23andMe or Ancestry DNA, and could theoretically be done for less than $20, and someday it will be, hopefully in the near future. So Ali Turkamani in our group wrote a wonderful review article, if you're interested in this topic, last year. And it's this whole idea that common conditions, like heart disease and others that I'll mention, hundreds of different letter changes in our genome indicate the risk, and you can get a score, and that's what this is about. So these conditions, like not just heart disease, atrial fibrillation, diabetes, breast cancer, prostate cancer, inflammatory bowel disease, they all have scores. And this was a recent article in JAMA saying that these scores for common complex disease will become part of clinical care in the near future. I would submit it should be today, but we're not really ready for that to get people their information. So, excuse me, this is an app that we prepared, Ali Turkamani and the team here at our institute, called MyGeneRank. And while you're here right now, if you had a 23andMe, you can upload it to the app and you can get your heart disease risk score. and hopefully it'll be real low. So that is a step in the right direction. It's free. You are agreeing to participate in a research program if you do it. And just today, in Cell, one of the top biomedical journals, we published, Ali and I, the obesity risk score, the editorial about that paper, which is, it's harder to know what to do with that, but it's something you can see in children when they're very young. And the question is, if you knew that the child was destined to have obesity later in life, could we intervene? Is there a way to do that which is palatable? No one has the answer to that, but the risk now can be defined, and it's really quite extraordinary. Now let's switch from genomics, which is clearly not gotten out there in a really big way yet, but it's just starting now, to sensors, which really are much easier to adapt to because we all have smartphones these days, and there are sensors for every part of our body, every system in our body. One of the deep learning algorithms that was the first one approved by FDA for patients and the public was the atrial fibrillation detection. So what it does is it picks up if your heart rate is normal at rest or with activity for you, and gives you a signal that you should record your cardiogram through your watch if it's off track for you. And so this can detect very accurately atrial fibrillation and may be useful in certain people. But beyond that, the idea is that you can do the same sort of thing for people with kidney disease who are at risk of developing very high potassium. You can get, without any blood, a very accurate potassium, which is pretty remarkable. And that is giving you a sense that machines can see things that humans can't by training with millions of data points. And that's what something human vision could never see from a cardiogram, whether the potassium is 4.3 or 4.4. So this is a blood pressure watch that's now FDA approved. We've been testing it. And this is really interesting because it gets you blood pressures at the least likely times, like when you're in traffic, or it never occurs in San Diego, I know, or if you're having an argument with your spouse. That doesn't occur either, I'm sure. But I've been testing this. It's remarkably accurate. And so we are moving towards being able to have blood pressure much more ideally, even without having to press start in the times ahead. Glucose sensors have really zoomed forward, whereby a glucose sensor, it doesn't even need a finger stick calibration anymore. So it's factory calibrated, and you get a glucose every 5 minutes. And this is really going to turn out to be on your phone or your watch to be very helpful, as I'll talk about in a little bit about diet and artificial intelligence. And now, connected sensors. In the city of Louisville, Kentucky, they gave everybody a connected inhaler who had asthma. Just by doing that, they reduced asthma attacks in the entire city of Louisville by 50% over the course of a year. And they reduced the need of inhalers by 70%. So it just shows you a remarkable impact of people knowing where hotspots are, where air quality issues are in one city. Now, my favorite app of all is the smartphone ultrasound. And this is remarkable because you just pop this onto your smartphone, this probe, and you can start imaging any part of your body except your brain, okay? And I think it's a remarkable advance. It isn't being used in this country that much, tied to issues like reimbursement, but it is really a stunner because you get images that are exquisite, as we've published, that are as good as the $350,000 machine that sits in clinics and hospitals. This is what it looks like, the heart. That's my area of interest. And you see, this is typical images of the heart. You see every aspect, the chamber size, the strength of the heart muscle, the valves, everything, in seconds. Why would you listen to Lub Dub anymore when you can see everything? And you share it with the patient, and you can send the patient the video loops, and it's a whole different world, which is remarkable. You can even track the leaks of the valves with this. So I haven't used a stethoscope in almost a decade. Why would you do that when you have this? So I was so enamored by this, I think you would probably do something very similar if you had this in your hands. I decided to do a total body medical selfie. So I did my carotids, my sinuses, thyroid, lung, heart, the liver, kidney. By the way, I didn't know how to do these. I only knew how to do the heart, so I had to Google it to find out how to do it, which is easy, by the way. Gallbladder, iliac artery, spleen, aorta, inferior vena cava, popliteal fossa, and my left foot. Now, what's really interesting about this is I didn't know it would pan out. I thought I did it as kind of just an educational experience. And then a few months later, I had some abdominal pain. I didn't know what it was. So I was scanning my abdomen and I found my kidney was dilated, my left kidney. So I went to the emergency room here and I told the emergency room doctor, I have a dilated left kidney on my smartphone here. That's not kidding. And he thought I was an alien. At any rate, he didn't believe it, so he sent me for a CAT scan, which is shown here. And if you look closely at the images, particularly if it wasn't so light up here, you would see that this very expensive image here is identical to the one on my smartphone. And it was free on my smartphone, but I didn't believe it. Anyway, I don't recommend this. This is not a pleasant experience to pass these stones. But it did show that the amazing capabilities of having a smartphone ultrasound, that is, gathering information. This someday will be something that consumers will widely have access to. Now, this week in Tuesday's New York Times was an article, even though this smartphone ultrasound isn't being used that much in the US, here it is in Africa. It's used widely in rural Africa hinterlands. And it's diagnosing everything, for like pneumonia, and you see here, I mean, you name it, it's an incredible article if you want to take a look at it, if you didn't see it in this Tuesday's New York Times. Now, beyond that capability, now this empowerment, like I showed you with heart rhythm, is going to urinary tract infections, one of the most common reasons to go to a doctor. Not in the US, of course, but in the UK. And so these are the various companies that have this, and this is using artificial intelligence. And the first one, Healthy.io, is actually in contract with the NHS in the UK. And so you can see how it works. I had muted this, but yeah. Yeah, that was quick, but the whole idea is that this was trained by hundreds of thousands of people who had urinary tract infections. So it's highly accurate. And that's going to be, for many people, the way to bypass having to go to a doctor, get a urine culture, and all sorts of other things. So just to leave you with the sense about the smartphone, that it's becoming the hub of the future of medicine. We're just seeing the beginning of where this can go. And this is going to be really important eventually for those of you who want it to be a virtual health coach all the time, helping you to prevent illness that you might otherwise get or manage ones that you have. So I want to talk about where we're implementing this, and Jamie mentioned this large grant that we have, this All of Us program. This is run here at Scripps by Katie Baca-Motes in our group, and this is an amazing program. You're certainly welcome to join. We have 180,000 of the million people in the US that have registered. More than half are underrepresented minorities, which is just in itself historical. No research program in the world has ever had that much representation by minorities. And this is the website if you want to join, joinallofus.org. And we'd certainly, the idea would be all these things that I've talked about will eventually be participants' choice. If they want to have their genome sequenced, if they want to have their gut microbiome assessed, they want to use these sensors. And so we're testing a lot of these things to eventually distribute them. Now let me get to the main topic, which is artificial intelligence, these neural nets, which is what is the excitement in medicine. This is from an op-ed by Thomas Friedman in the New York Times. In January, he declared that the word for 2019 is deep. I said, oh, that's great. That's the name of my book. It's great. And he was right. It really is true. I wrote this high performance review in Nature Medicine, and of course the book, it is about going deep. is using this data, deeply understanding each human being, using deep learning to move that data into an understandable and predictive format, and then to restore this deep empathy. So it started about 10 years ago. So the Turing Award, which is a Nobel Prize in computer science, was just awarded a little over a week ago to Geoffrey Hinton and his colleagues from the University of Toronto, because they took images like cat videos, but not cat videos in this case, and they were able to use deep learning neural nets to get accurate depiction of these images. And so now that's being used in everything that you can imagine in healthcare. The concept is this: there's inputs. It could be an image, it could be a slide or an eye scan, whatever electrocardiogram. It could be speech, it could be text. It goes through all these layers of artificial neurons, and those layers, the number of which are not dictated by a human, a programmer, it's by the data itself. And then there's an output, which, as this gets really good, because these neural nets have insatiable appetite for data, unlike humans that have early satiety. So this gets good, and then it gets really super accurate, as you'll see. So the leading discipline is actually ophthalmology. A lot of people think it's radiology, but it's actually ophthalmology. And so the first thing that really is shocking is if you show this eye retina picture to international retina experts, and you say, is it from a man or a woman? And the answer is 50% right. 50% right. Now, there are other ways to tell whether it's a man or a woman. I know that. But 97% accurate with the neural net. And no one knows why. Because it's been fed 1 million retinal pictures with the right answer as far as gender. That's, again, to show you seeing things that humans can't see, right? Training, for example, in Moorfields Eye Institute, the leading eye institute of the world in London, where, by the way, they do optical coherence tomograms in everyone for their annual eye exam. We don't even do that here, except in rare occasions. And OCTs are the best way to see the retina and diagnose a whole host of eye conditions, and we don't even do those routinely. So for people who think that we're so advanced here, and eye conditions are really important, and they were able to show with an algorithm, a neural net algorithm, deep learning, that they could diagnose over 50 different eye conditions more accurately than retinal experts and other leading ophthalmologists. So I'm not going to go through all these, but every single clinician, every type will be affected because of this capability. And just to give you some other examples, radiologists. Did you know that over 30% of scans are false negatives? 32%? That means they missed something important, okay? That's pretty bad. And that explains why there's so much litigation, and radiologists are expected to read so many scans. No wonder there's a problem. And now we're seeing AI companies that have been approved for algorithm support of radiologists in the US. Here's an example. Lung nodules that could be cancerous are missed a lot, and now they're not really missed when you have artificial intelligence to find them and then oversight by radiologists. Here's wrist fractures, which are frequently missed or misdiagnosed in the emergency room setting. This can help emergency room doctors become superior wrist fracture diagnosticians. It's not just radiologists, here's pathologists. Can you imagine this? That the pathologists can't tell what mutation it is by looking at the slide that's driving the cancer. But by training with algorithms, it can diagnose what is the mutation besides whether it's cancerous or not. It's pretty striking. Again, the human vision limits versus machine vision training. And what about a cardiogram that you could tell the heart function? We never thought we could do this from a 12-lead cardiogram. Now we can, from Mayo Clinic work, detect what is the function of the heart. Skin lesions. Why would you go to a dermatologist when you can get the answer better than a primary care doctor or a dermatologist by taking a picture and having a deep neural net applied to that picture. Because now, compared to hundreds of dermatology experts, the results were as good or better with neural nets. And then this is colonoscopy. This is, of course, everyone's favorite procedure. And what's interesting there is that so many polyps are missed. So many. And now they're not going to be missed because deep learning of the video, real time, randomized studies, both of which are from China, have shown that you won't miss these polyps. So it's pretty striking. But it isn't perfect. We have seen, for example, a study of congenital cataracts, which are difficult to diagnose, where trained ophthalmologists are better than the algorithm so far. So it isn't, I don't want to give you the sense that this is all buttoned up. But we do have to test these things in clinical trials and then keep this under tight surveillance, because if an algorithm has a glitch, if there's malware, or if it's being used in a different population from which it has been tested and validated, it could create lots of potential harm. Now, I had the opportunity, speaking of the UK, of being commissioned by that government to run a review of planning for the next 20 years using AI. And this was a really exciting opportunity to learn about the NHS, which, by the way, unlike the US, the NHS is regarded above the royal family and the BBC as the most revered institution in the country. Not like what we think of healthcare in the US, right? So we did a review and we ranked all the different technologies that are going to have an impact. AI is the most transformative of all. And I think it's really clear that they are planning ahead. We are not doing any planning. We had an announcement earlier this year of the American AI Initiative. $0 were allocated, 0. And we have no planning in this country for the use of AI in anything, no less than healthcare. So now let's turn to the clinic. We talked about the doctor that's looking at the keyboard and the patient that is saying, what am I doing here, right? Well, now it turns out there's over 20 companies that are using another form of AI called natural language processing, NLP, to synthesize the note, to liberate from keyboards. And much better notes, by the way, already implemented in the UK, hopefully soon here in the US, to get rid of human scribes. There's over 50,000 human scribes now in this country that are there so the doctor can look at the patient. It's amazing. So we have to do better than that. That's like going back to before Gutenberg. You know, that's really kind of difficult. So this is the most famous painting ever in the history of medicine. It's called The Doctor by Luke Fieldis. This is a modern depiction of that here, you see. We want to move away from this, okay? We want to get restoration of caring for patients. Now, in the UK, the reason I mention it is economists, were involved in our multidisciplinary review. They found that even just 1 minute of liberation from keyboard, it was one of the most productive things you could ever have in healthcare. It equated to an enormous number of increase in doctor slots to see patients and care for patients. So this is an effect that's not only having all clinicians, but across all the health span. Everything from before an embryo is implanted all the way through one's life at the stage of potential end of life. And just to reinforce that, this was published just last week, and it's a study which is pretty remarkable because so many embryos are discarded that actually are of high quality, but it's because the embryologist that's advising the couple can't discriminate because it's so subjective. Now, using machine vision, the number of embryos that are of good or high quality is markedly augmented. That's really exciting because you know the problems we have with in vitro fertilization and successful term pregnancy. I want to show you this about the patient status today.
Can you let the doctor know that I'm breathing shortly? I am getting a lot of work done here. My body is very fast. But he's very breathing. I'll be with him as soon as I can. Not yet, but you're next.
Okay. So that's the beginning of the movement. And when you have data that's eminently portable, and you have people with high-speed internet connectivity, there's no need to have paternalism. And the patient will see you now, is so well graphically shown there. So for patients, what is AI going to do for patients? I already mentioned things like heart rhythm and UTI, but I thought you'd be really interested in diet, because a lot of people would like to have their diet be part of their medicine. They're promoting their health. Food is medicine. Wouldn't that be nice, instead of having to take prescriptions? So this was a Time feature about this whole concept, but recently I wrote an essay for the New York Times, if you saw it, called, I didn't call it the AI diet, they did, but that's essentially, we cracked the case, finally, with AI. And it wasn't we, it was actually the group in Israel at the Weizmann Institute a few years ago. The point being is, up until now, you've seen all these guidelines about what you should eat and food pyramids, the same diet for everyone. Is totally wrong. Totally wrong, because we each are unique. Why would we eat the same diet? So finally, the group in Israel cracked this case, and they published a paper in Cell. They published a book called The Personalized Diet. And the point being is, all of us ate the exact same food, the exact same amount, the exact same time. Our glucose, after we ate, would vary all over the map. And that has been replicated by many other groups. And now it's been extended to your triglycerides in your blood. So we have a unique response to food. Finally, we have nailed that. And the way it was nailed was, they gave thousands of people in Israel these controlled food diets. They measured everything, including glucoses and their gut microbiome and all the different layers of information about each person. And they showed that there was this highly individualized response, and much of it, not all, but much of it was actually influenced by your gut microbiome. So the accompanying editorial was, Siri, what should I eat? And I'm not sure that we would want to rely on Siri, which is not a very advanced form of NLP, but you get the message. So I decided, I thought this was really cool. I want to try it. So I wrote to the fellows who I'd met in Israel, and I asked them if I could get a kit and be one of their participants. So I did, and I had a glucose sensor, and I had a lot of spikes. And I don't have diabetes. And in fact, a lot of you, if you did this, would have a lot of spikes to certain foods that you would never have predicted. I also had my gut microbiome, and I had to type into my phone everything I ate and drank, and every sleep and physical activity and medications. It was a real pain in the neck to do this for 2 weeks. And it isn't available. This package is not commercially available. There's scaled down things that I don't believe really work, and you'll see this might not even work either, but it was an interesting experience because it gave me output of everything I should or shouldn't eat for me to avoid glucose spikes. And one could argue, well, maybe glucose spikes are not the be-all and end-all endpoint. But nonetheless, my favorite foods got a really poor rating, and the things I would never go near, like bratwurst, cheesecake, things that I thought were potentially lethal, they got A+ ratings. I said, this is incredible. So, anyway, we're heading that way, where you will, if you want, have a diet that will tell you how to avoid glucose spikes, how to avoid triglyceride spikes, and many other things that are undesirable. It'll take years before we have randomized trials to show that it prevents diseases like diabetes or heart disease. But interim, this is coming, and you might be ready for it. You'll see these sort of things over the next couple of years. And then lastly, about the levels of influence, I'll just say the health system has big impact because you can do remote monitoring for years for the cost of one night in a hospital in the US, which is over $5,000 charge. And so we have sensors that we can do that, and we're going to have all sorts of AI to replace hospital rooms. Not the ICUs or not the emergency rooms or operating rooms, but the rooms in a hospital. So just to kind of pull this together, we are still at the early phase of taking in this multimodal data, like sensors and genomics and your electronic record, but that's where this is headed. And what that gets us to is not an autonomous form of healthcare for certain things, like a ear infection or a skin lesion, yes. But for most things, it still will require human doctor, clinician oversight. So unlike driverless cars, which will never be fully autonomous, we're not even going to get to the point where they are, because here, anyone with a serious diagnosis would like to have human contact, human oversight to make sure that it's right, and what are we going to do about this? And also to learn about the person's story. So learning about each person, deep learning, is going to look like this. This virtual coach is going to have all of your data if you want to sign up for this. It's also going to have the corpus of the medical literature up to the moment relevant to you. And it's going to have an avatar talking to you one way or another to give you advice. And in the book that you have, you'll see many examples of what that's going to look like in the near future. It's pretty exciting because this is all possible. And if you talk to the AI gurus around the world, they're very excited about what this can do for the future of healthcare. So basically then, when you have doctors that have less tasks, less or no data clerk function, more time, and you have patients that are taking on more charge, you have a flywheel effect where you can actually see the restoration of the care in healthcare, which is so exciting, which we've lost. There's been serious erosion over the last at least 3 or 4 decades. And that is the most exciting part of this. I don't want to leave you with the sense that there aren't serious issues that have to be addressed. There's a chapter, Deep Liabilities, in the book that addresses all these serious liabilities. My biggest concern is not about these. They're all important. My biggest concern is whether this great jump in productivity, efficiency, and workflow, and accuracy, and speed, which would give the gift of time, would it be used to make things worse? That would be the default mode if we don't stand up and say, we need to give this back to patients, give this back to the relationship, the human bond, the human touch, the deep empathy. So this is just, Abraham Verghese is the leading medical humanist of our era. He wrote the foreword of the book, and he has in that foreword a quote from the book, Intoxicated by My Illness. And he recalls this one part about my soul as well as my flesh to get at my illness, for each man is ill in his own way. The point being is, we will never digitize a person's life story. That's the essence of medicine. That requires time. And that's what we want to get back to. And those of you who are old enough to remember, 40 years ago, when I finished medical school, that was routine. But we've lost that. We've lost the mission for doctors. We need to restore that because they don't want to be data clerks. They don't want to be saddled with all the little time and little ability to provide care. So what we need to do today, human performance is not going to change. It may vacillate a little bit, but over the times ahead, it's pretty stable. And what we want to do, we know machines are going to keep getting better. That insatiable appetite for data and algorithmic training, they're going to get better on so many tasks that we are just seeing the beginning of that now. What we need to do is get more human, more humane. And if we do that in healthcare, we can make a really big difference. It's really exciting. So I just leave you with this, get back to the deep stuff, deep understanding of each person, deep learning to deal with that data, and the restoration of this deep connection and empathy and restoration of way medicine used to be. These are all the people I get to work with, a real privilege in our group. And working at Scripps Research is a dream to be able to be creative and innovative among an extraordinary community of faculty and grad students and everybody here. It's just an amazing place, and no wonder it was ranked #1 by Nature for Innovation Place. So I'll leave you with that, open it up to questions. Thanks so much for your attention.